Good morning, everyone. My apologies for being a few minutes late. We had a little timing issue going on. I'm Suzanne Florek, VP of Marketing at Wavelogix, and thanks for joining us. Today's discussion centers on a major industry shift. On April 21st, Iowa DOT revised IM 383 to formally recognize acoustical resonance under the AASHTO T412 as an approved method for estimating in-place concrete strength for state projects. That means contractors now have a real-time alternative to traditional cylinder breaks with live in-place strength data directly from the slab. For Wavelogix and the Rebel system, this is a significant milestone, and today we'll walk through what changed, what it means operationally, and how teams can begin applying it immediately on projects. Before we begin, a few quick housekeeping notes. This session is being recorded and we'll send the recording and slides afterward. Please use the QA feature for questions throughout the presentation. We'll address as many as possible at the end. If you experience any technical issues, drop a note in the chat and our team will assist. I'm joined today by Joe Turek, CEO of Wavelogix, and Felicia Bahr, our technical sales specialist with extensive experience in DOT concrete testing, QC, field operations across commercial and transportation projects. Over the next 30 minutes, we'll cover what changed in Iowa's specification, why real-time strength monitoring matters operationally and financially, and how the Rebel system works in the field. Thank you for being here, and let's get started. Joe, I'll turn it over to you.
Fantastic. Thank you, Suzanne. Welcome, Felicia. Welcome, everybody. It's great to have you back. So we're excited about this session today. Exciting news. Iowa, as Suzanne had kind of said it lightly, it was really earth-shaking as far as we're concerned that Iowa was the first state that actually has approved the use of our acoustic Rebel sensor to be used as a replacement for cylinder brakes, completely replacing cylinder brakes in maturity. So that's really great. And so if we just look at how that really changes things, first it was revised spec 383. They kind of snuck it at the back of 383. You'll see 9 pages of write-up of maturity, and then just 3 pages of how you install the Rebel sensor, what it is. That lends to how simplistic our device is to be able to use. You can completely replace the cylinder brakes and use the sensor reading to certify your strength. And that's going to allow you to do a lot of things. See real-time data, get paid earlier, finish the project sooner, and lower the cost of cylinders by 50% using our systems. So it really is a game changer right now in Iowa. So good job, Iowa, for moving forward with a great technology. A lot of work done on their team to test the product throughout the year. Felicia, anything that I missed that you'd like to add?
I think this is huge. I mean, not having to rely on cylinders itself. I mean, we know cylinders is a lab test where this is actually in place. So this is huge. This is a game changer for actually field conditions versus lab. So I'm really excited.
Yeah. And for those of you who don't know Felicia, she's joined our organization just a little over a month ago. We're so excited about having her. She spent her career making cylinders. And she was so tired of that. She said, Joe, can I join your organization? I just love your sensor. I got to get out of this cylinder business. Now, that's an overstatement. I'm sorry, Felicia, but did you ever really like making cylinders?
No,
Yeah,
no, not always.
it paid the bills.
Yeah, exactly.
This is an easier way
Suzanne,
to pay
anything to
bills.
add? Yeah.
No, I'm good. I think you've completely nailed it. But a big shout out to Iowa as a thank you.
So what's really changed in IM 383? Before you had cylinder brakes that followed AASHTO T412. You had to verify your strength at 1, 7, 14, 28, 56 day breaks. Your payment was tied to cylinder results. You had to wait for the lab to get you those results. Those weren't necessarily always timely, depending on who you're using. And if you had to arguing over what the real strength is, and sometimes having to have to do a core sample, which gets really, really expensive. Um, and you don't really get in-place data. That's one of the problems we've always had with cylinder brakes is they're external to the actual slab. So are those cylinders truly giving you a real representation of the strength? Now, after with IM383, this is kind of exciting. First of all, the our Rebel sensor that complies with the AASHTO T412 is now approved for use. It's real-time in-place strength right inside the slab. So you're reading the strength of that slab and all its effects on the curing of the concrete. Your payment is going to be authorized now by those readings. You don't need to use a cylinder to verify it. There's no calibration curve. There's no beam casting. There's no maturity setup. When you read the IN383 spec for maturity, if you've used maturities sensors before, you're going to have to do a lot of calibration. It's a lot of work. And this applies to pavements and all structures. Felicia, anything to add?
Well, the really cool thing about like doing the difference is like the biggest thing with testing for pavement opening and all that kind of stuff is you have that overtime. All this technician overtime hours, they gotta break those cylinders at 8 hours, whatever they need to be. Now there is no technician. You're not paying for that technician to come in and break cylinders and then possibly have to wait just because your cylinders didn't actually meet at the 4 hours.
Yeah, good point. Sue, you missed anything?
No, I think you're on task here.
All right. Not all burners. Problems with cylinders for sure. Sometimes you have to wait to 28 days for payment, waiting for that final strength. Coincidentally, our sensors typically, we've seen through the thousands of sensors that we've deployed, you hit certified strength today about 10 days earlier than 28 days, somewhere in the 18 to 21 day mark, which is really huge. If you can complete a project early and submit your paperwork for payment, that really is huge. Waiting for those milestones, you're seeing the data in real time. And like Iowa in their spec, they're letting you make decisions strictly on what the dashboard is telling you your strength is. That's great. Um, you know, you're not paying twice, or if you're using cylinders, you're going to pay twice. You've got the cost of the cylinders, and you still have the cost of people doing it. And big time when brakes fail, is there anyone out there? Raise your hand if you like cylinders. I don't see anyone raising their hand. I mean, they're just horrible. I'll do a shout out to Forney. I just got their blog number 6. They've done a great job of talking about testing concrete through different stages. And the last test today, coincidentally, was doing cylinder brakes. Oh my God! You read that blog, and I guarantee you, there's probably very few technicians out there that are following the letter of the law. Felicia, you've made a lot of cylinders in your time. You can talk probably for days on cylinders.
It definitely is a process, that's for sure. And it's a very important process. It makes a big difference.
Yeah. It's one of the things I think it takes it out of the control of the contractor as well. Um, you have a third party, a test house, typically someone who's doing cylinders for you. You're relying on their expertise. And if they do it wrong, you're the one who suffers. The test house really doesn't take any responsibility. They're just like, oh, it's the brake is what the brake is. And you think you made the cylinder wrong? No, we couldn't possibly have done that. We're the experts, right? And then the whole cycle begins.
I just shared that blog with everyone in the chat if anyone's interested in reading it.
Oh, you do. Great. Great. So it's a lot of fun. Um, and on the scene, meet the rebel. This is the new technology that makes your life simplistic, which is great. You embed the sensor. It uses a piezo disc to create an audio signal that goes into the concrete. There's no calibration that's needed. That is really huge. On top of that, it's agnostic to any type of mix design. So you change the mix on the fly, you don't need to recalibrate it. Our sensor will read any type of concrete. If there's a problem with the concrete and you deliver the wrong stuff, it's going to figure that out. So it's really great. And it gives you live real-time strength right on your phone, your laptop, your tablet. You're seeing the data, which you've never been able to see before. It is really, really kind of cool for the first time when you start seeing this and you're watching your phone and you start to see the plots of the strength growing, and you're like, oh my gosh, how do they do that? Well, it is a little bit of magic, but it's really, really neat technology. Felicia, what do you think? You've had a chance to
Well,
compare this now to what you've been doing for a career.
yeah. Yeah, I mean the no calibration curve is the game changer for sure. I mean, all those maturity curves, I mean, especially with type 1L and the differences that's causing. I mean, you'd have to run maturity curves all the time. There's no knowing if your maturity curve is always accurate, if that fluctuation happens, and then all of a sudden you're running calibration curves right on the fly, and it's just not ideal. So the fact that there's no calibration curves is just amazing, and the technology is just like it's really cool. It's very exciting. It is very it's very futuristic. I love it.
Plus, you can see all of your results right on the dashboard from your phone or from your computer. You're not having to go out there to figure it out.
Yeah, or wait for a test house to send you an email.
Yep.
Yeah, nobody has to do anything. Put your feet up and just watch the screen. So it's as simple as one, two, three, right? Embed the sensor in the concrete. Make sure you have 6 inches of concrete over the sensor. It can be placed on the ground. It can be tied to rebar. You just want to make sure that you have 2 inches of clearance above the sensor head. There's no rebar going over it. Very, very easy to deploy. Um, Once the concrete pours over the sensor, it automatically senses the concrete pour, and then it starts displaying the data almost immediately, every 30 minutes for the first 48 hours. Um, so it doesn't get easier than that. And certifying, we've got strength plus 10% triggers, notification. So for instance, X, which is comparable to 275, 2,750 PSI compressive strength, then you add in 10% on top of that, and your specification is 3,850 for compliance. So it's pretty straightforward. They built in Iowa was smart enough to build in a little bit of fudge factor in there, but as I had mentioned, we see an early strength between 1 and 5 days, usually about 2 days getting to strength before the cylinder would be able to tell you were at strength. And on mid strength, where you were typically doing a 7 day cylinder break, you get to that strength usually around day 5. So in every step of the way, early and mid strength, you're saving time, you're getting to the strength sooner. And then in certified strength, as I mentioned, probably 9 to 10 days even sooner than the 28-day spec.
What is one of the things that you find new users of our system are just like, wow, is this really what's happening? Because
Yeah,
it's
it's
kind of mind-blowing. It's new, it's
yeah,
different, and it's
yeah.
sometimes hard to wrap your head around.
Right, right. Is this really right? Can we trust it? It really is pretty good. Once you get comfortable with it, you never want to go back. You never want to go back to cylinder breaks. You never want to go back to maturity. It's so easy to deploy and use. It just makes perfect sense.
Joe, maybe you want to cover a little bit about just the pros of our dashboard.
Yeah, the dashboard, and we can get into that a little bit later, but the dashboard is very user friendly. It gives you a lot of opportunities. If you have multiple sensors on a pour, um, so usually we'll see 2 to 6 sensors on a pour. You will see all of those sensor data established on that pour at the same time. you compare that to an expected strength that the user puts in, so they have a gauge to see if they're hitting what the ready mix company has told them their strength was going to be. And then you have the ability that if you were comparing our sensor to cylinder brakes, you have the ability to put in cylinder brakes or other information in there. All that data then gets compiled at the end of your pour, and with one button, you can just print out a report that you can submit then to the DOT or to your customer that gives them all the information that you would normally sit there have to hand tabulate and get from the test house and get from the test guys and pull in all together. It's all in one place, and makes it very easy to get your final data. Maturity method, just a comparison to that, is only good for early strength because it measures the heat of hydration. So a lot of people use the combination of maturity for seeing what was going on early strength to do things like remove forms and cut concrete. And then they would use cylinders to kind of break up the to get your final certification at 7 and 28 days. But to do a maturity test or to set it up, you're going to have to do a curve in the lab. Per the spec required like 12 beams. It's gonna be mix specific. So every time you have a different mix, you'd have to do a new curve. You had to recalibrate those curves every 90 days. It's time and temperature estimate. And again, after 24 hours, that temperature starts to decay. So you're estimating cooling rather than heating, which is very difficult to measure in environments that are very cold or very hot, because they're going to have more effect on the concrete than the concrete itself. And then, you take your first reading after the curve is built, and that curve usually takes about 7 days to create. Rebel, there's no pouring in the lab. There's no curves to be generated. It's mix agnostic. There's an annual sensor calibration process that's done at the factory, and it's a direct place strength measurement all the way up to 28 days to 56 days. You can come back a year from now and measure the strength of the concrete. Our sensor is not dependent on temperature. It's dependent on acoustics, and as long as you maintain the integrity of the connector, you can plug back in and take a reading anytime. And we start reading immediately after the first hour, once the concrete has gelled enough to have a strength, and then go from there.
Yeah, and the biggest thing with maturity, as you said, with the curves, I mean, it is mix specific, but it's also anything that changes, like if you got a new cement source, new aggregate source is coming from a different plant that has different sources, technically you would need another calibration curve. So you could end up needing like 3 or 5 different curves just for one mix. And then, if you got 10 different mixes on a job site, that's super costly to do. I mean, you got technicians, you got at least to do one maturity curve, you got at least 3 technicians running the test itself to try to get that calibration curve. It's just super timely. And then if anything goes wrong, you got to redo it again. So it is still a lab test. That's the biggest thing. It is always and still a lab test. Similar to cylinders, it's lab driven, it's not field driven. So I love that this is field driven.
Yeah. Yeah, we had one customer that in his organization, he was trying to convince them to use our Rebel sensor, and they were resistant because they were longtime users of maturity. And then all of a sudden on the job site, they heard that the truck broke down and they had to switch to another plant, and they didn't have a maturity curve for it. And what were they going to do? And oh my gosh. And he ran in with the Rebel sensor and saved the day and said, just use this. It'll do the job. And they were convinced after that and became a loyal customer, switching from maturity to the Rebel. Hopefully our conversions go a lot smoother than waiting for a disaster to happen. When can you open by the numbers? That's every customer has a final certified strength, or a time when you could start opening traffic, and it varies from state to state. But typically, you start seeing states allowing opening their traffic somewhere around 2,700 to 3,500 psi, and final strengths usually 4,000 to 6,000, depending on what they're trying to do. And Iowa specifically has some three different touch point numbers to allow you to do certain things. And if you just look at a checklist of what you do before the pour, just confirm that you have the correct quantity of sensors that you need for the volume of the pour. Inside the spec, it does tell you how many sensors you're going to need based on the volume that you're going to be pouring. So that's important. Make sure you have enough. Place the sensors. Make sure they're in a place that you're going to get 6 inches of coverage. Coincidentally, if you had something that was less than 6 inches, an overlayer that we sell a cylinder that has the sensor inside the cylinder, and that could be used as a substitute for in place, because that will give you the 6 inches that you need in the cylinder. The During the pour, you're going to get readings starting within an hour or so once the concrete gels, and then you're going to start seeing that every 30 minutes. And then after a couple days, then it starts to move to 6 hours a day. The curve doesn't move that fast or change that fast, so we don't necessarily do readings constantly. And then you're constantly monitoring the compressive strength. Before opening, make sure that you hit the strength that was specified, and the engineer approves that or authorizes it. Now, the nice thing is you can set up, if you're a contractor, you could set up and with an engineer, you can give them access to your dashboard, and you could just give them a call and say, hey, listen, look at the dashboard. Our sensor has reached this particular strength. Am I good to go? No one has to come out to the field necessarily. Have multiple people see the growth of the sensors. And if you have multiple projects going on at one time, you get a master dashboard that can see all of your pours happening at any one time. Having you have to run out to every site to necessarily check and see what's going on with compressive strength. And in the end, submitting your documentation, again, as I mentioned, kind of a one-button push, and out comes a PDF that you can send to your customer.
I linked in the chat our field guide. If you want to just review any of that on your own, you can see it kind of quickly and effectively as to how easy it is to deploy our sensors.
Yeah, the
Yeah,
field
and
guide's been really helpful because it's just you can pick it up right on your cell phone, and you can just to go through a real quick checklist. Did I do everything right?
yeah, and my favorite thing, Joe, about the dashboard is that predictive curve that we give them. When do we typically see that projection curve for your sensors?
So that's a really good point. After 3 days, we start to project out where the concrete strength curve is going to most likely end up, all the way up to 28 days. So if you are having a problem with your concrete and you're not going to make certification strength, you're going to know about it in about 3 days. And there's so many things you can do to potentially mitigate damages if you know sooner than later that you're going to have a problem. Typically, if you're doing cylinder breaks, you don't want to believe that your concrete was not coming up to strength, and so you're waiting longer, you're doing more cylinder breaks, you're hoping that the cylinders were wrong. And if in the end the concrete was really not correct, you wasted a lot of time, almost 2 months in some cases, before you actually get results. And then you're ripping up concrete or getting paid less. A lot of bad things happen. So better that something happens sooner than later.
And I also just put one more link in the chat on our sample pour report so y'all can see what it looks like.
So reasons for contractors to replace cylinders. If you don't absolutely love them, first of all, you get potentially paid faster. Your project is completed faster. You can be moving on and be approved to move on. The roads can be opened sooner. And the cost is half the cost of cylinders. So, there's benefits all the way over, all the way around. If we just kind of let's look at just some real life situations where the rebels help people save money. Caltrans project and the I-10, the contractor got paid 12 days earlier. That put a little bit more coin back in his pocket. Not huge, but that was got paid earlier. We didn't even calculate the effect of maybe not having crews on site for those extra 12 days. Sometimes you don't have so much, but there were things that you can move forward on. So that's, I think, is a great benefit there. Road patching, Texas DOT does a lot of road patching. Typically, they were waiting 3 days to release traffic, and time is money in traffic situations. We estimate about $100,000 a day in delays through economics of people being delayed getting to work, traffic jamming, et cetera, et cetera. So, they saved almost 2 days on there, got traffic moving in a day rather than 3 days, and made a lot of people happy about that. So that $200,000 of savings, looked great for the contractor, looked great for the state, and it wasn't too expensive in terms of rebel cylinders. ODOT had a bridge. This one was really kind of interesting. It was a very cold day, and so the concrete was lagging and curing. They had used a cylinder, and they were telling them that they had strength that was stronger than it actually was, and they were in the process of doing post tensioning, so they ended up waiting a couple more days. And had they done the tensioning when they thought they were at strength, most likely would have damaged the bridge structure altogether. They avoided almost $400,000 in cost in replacing concrete over the next year, and at a very, very minimal cost in terms of rebel sensors. So a lot of our customers like to think about the rebel as an insurance policy when you get real-time data and mitigating real potential damages. As we mentioned, it's really simple to deploy these. You can either drop them out right onto the ground and pour concrete over them, or you can tie them to rebar. The sensor is a 4-inch disc, has a 16-foot cable that comes out that can be extended up to 100 feet if necessary, and that plugs into the data logger. The data logger is the brains of the operation that excites the sensor, takes the sensor reading, and then sends that information up to the cloud, where we use a machine learning algorithm to convert the sensor data, the acoustic sensor data, then into compressive strength. So pretty simple system. And we've had very good success with contractors first time out of the box deploying the system perfectly. So
Yeah, and the best part about the data logger, my favorite part of it, is it's LTE network. It's all cell network. It's not Bluetooth. You do not need to be on the job to read anything. It automatically uploads to the cloud, and that's game changer there.
yeah, yeah. We find it working in just about every type of environment. The data logger is sealed, so you can get it wet. It's pretty indestructible. It has a battery in there that's rechargeable, wirelessly recharged. It lasts 28 days on the job site. If you needed to go longer, we have a little battery extender pack that slaps onto the back of the data logger and can go longer in time. So it also has a GPS location in it, and so you know exactly where your sensors are located on the project, and you can go back in time to say, where did I place all my sensors? And you can just see them right on a map, right in the dashboard. It's pretty cool. So 3 steps before your next pour. review the Iowa IM 383 spec. And if anybody needs a spec, Sue, I don't know if you placed the spec in the chat, but you can request it from us. We'd be happy to send it to you. It's very comprehensive, and if you have any questions, feel free to call our tech team. We can explain that to you. Get a quote for your next project. We have three real nice little kits, the apprentice kit, the journeyman kit, and the professional kit. That's based on data loggers and sensors that you can use. The journeyman is a great kit on how to start. You get 6 data loggers and 12 sensors, and allows you to do multiple projects. And then after you have a kit in hand, you can just buy sensors independently or individually at larger volumes at a discount. You can always buy more data loggers. We completely support and warranty all the products. And the great thing is we ship out of stock. So if you called us up this afternoon, we can have product shipping out to you and you can have it at your site tomorrow. So pretty straightforward. And deploying it, we boarding session that walks you through all the things you need to know, how to get onto the dashboard, how to register the sensor on the dashboard and connect it up. We have had, I'd say, 98% success rate of walking folks through on the dashboard and allowing them then to deploy the sensors without any problem. We have the onboarding process is recorded. You can go back at any time onto our website and review it. It's a very self-sufficient type of system. Sue, you have the most history with a lot of this. Anything?
I've added a link
Or
to book a meeting with Don Nielsen, our VP of Sales, should you want to talk to him about anything. A link to our case studies and a link to our pricing of our kits. I will send out the spec in the follow-up email with the recording. And
great.
if anybody has any questions, we'd be happy to answer any.
And Felicia, you had an experience before you joined us. You were one of our customers who went out and deployed it. How would you say our process was from just training you to going out in the field? Was that pretty straightforward?
Honestly, it's like the easiest thing ever. I mean, if as long as you can navigate through a phone, I think honestly, I think anybody can navigate through it. It's not hard by any means.
That's great.
But if it is hard, we're there for you. We'll support you through the whole thing.
It's pretty darn simple.
Yeah.
Well, if I don't think we have any more questions, and we are running a little bit over in time. So, Joe, do you have anything else you'd like to say?
Um, like I said, this is really an exciting time, I think, for Iowa. A chance for you to finally eliminate cylinders and beam brakes if you were doing that, and use technology that's 100% sensor based to be able to make decisions. That's really, really huge. We're hoping for more states. We've been working with 34 states right now to adopt the technology as well. We've got multiple tests going on. We're getting very, very close with about 10 states that we feel could write us into their spec this year. So the folks in Iowa, you are trailblazers and leaders of the country, and those that work in multiple states. Once you start using the sensor in Iowa, talk to your DOT and say, let's get on board here. Come on, give Wavelogix a call. And let's get you into that spec. So it's all about the community. It's all about the use. So we hope everybody has as much fun with the sensor as we have delivering it to and developing the system. And we look for your feedback, and we're ready to support you in any way that you need possible. So thanks for your time today, folks, and we look forward to you joining us in future webinars and more information. And I appreciate my guests and cohorts in crime here, Felicia and Suzanne, for your words and comments as well.
Well, awesome. Thank you both for being here, and a special thank you to you, Felicia. And if you want to continue the conversation, please reach out to Don Nielsen. And we'll also send out the webinar recording and presentation materials after today. Thank you again, and a big thanks to Iowa. We're really proud and excited to be part of this. So thanks, and we'll see you next month on our next webinar. So talk to y'all soon. Bye-bye.
Bye-bye.
Bye-bye. Congratulations.